I hope you did these two problems and looked at this numerically and or graphically or both. So we want to find these two limits. Limit as x approaches 7 from the right and limit as x approaches 7 from the left of 3x divided by 2x minus 14. I'm going to do these numerically first. I have already set up the table here. So limit as x approaches 7 from the right means that we're going to plug in values of x, which are above 7. So let's do 7.1, 7.01, 7.001, 7.0001. Let's look at what output values I get. If I plug in 7.1, I get 106.5. If I plug in 7.01, I get an output, which is 1051.5. If I plug in 7.001, I get an output, which is 10501.5. And then 7.0001 as an input gives me an output, which is 105,001.5. So we see that as we approach from the right, these numbers are getting bigger and bigger and bigger. So we can say that the limit as we approach from the right is a positive infinity. Let's do the limit as we approach from underneath. Our input values are going to be under 7, so 6.9, 6.99, 6.999, 6.9999. When you plug in 6.9, you get an output, which is negative 103.5. When you plug in 6.99, you get an output, which is negative 1048.5. When you plug in 6.999, you get an output, which is negative 10498.5. And finally, when you plug in 6.9999, you get an output, which is negative 104,998.5. We see that as our x gets closer to 7, our outputs are all getting closer to negative infinity. They are getting further and further down. So we say that means we approach negative infinity. And that is how you do the limits numerically. Graphically means we're just going to graph the function 3x over 2x minus 14. When you do that, you can see that as we come in and approach 7, a lot of times it's nice to also put in a vertical line here, x equals 7, so we can see that it is actually 7 that our graph is approaching as we shoot off to infinity on the right and negative infinity on the left. And as you scroll out, you can see how that goes. These things get so close, they look like they're right on top of each other. So as you approach 7 from the right, you're shooting off to positive infinity. As you approach 7 from the left, you're shooting off towards negative infinity. So that's how you can look at this graphically. Before we move on, I want to point out that in both of my examples, the place that the limit shot off to infinity was at an x value of 7 here, which hopefully you noticed makes the denominator be 0. And in the previous problem we did, when x approached 3, again, that denominator became 0. So those are some interesting points.